All right, transhumanism lecture 14, I think 14. We're going to carry on looking at large language models. We're going to get into the scary stuff today of what's happened in the last 3 years. Uh, but before that, let's have a look at what happened in the last 2 days. Obviously, it's only 2 days, so not a lot. Um, every day, there's a new LLM, a new language model. This company, Mistral, is originally a French company, but they have US, a lot of operations in the US now. OpenAI, Microsoft all invest in this country, in this company, IBM. They mainly work on speech generation and speech recognition, and they released their new model for converting speech. It works in 9 languages and it's designed to work on cell phones so that better translation on cell phones and text to speech, etc. This company, a new startup that only started 2 years ago called Harvey, has just been valued at $11 billion. They build AI for lawyers. Uh, One of the areas where AI is meant to have a huge impact is in the legal field, doing all the kind of paralegal work. Yeah, these two guys set up this company, $11 billion in 2 years. Two articles this morning popped up on AI News, both to do with finance. Bank of America are now building AI agents to give financial advice to all their customers. So you won't be getting your financial advice from humans anymore. Bank of America is switching it all over to be done by AI agents. And another finance story popped up this morning as well that I read this morning. It's March 19th, but I only read it this morning. Um, Visa are preparing for a change to how they process your credit cards. When you buy something with a credit card, it's a human making a purchase on Amazon or in a restaurant, you're paying with a credit card. But more and more, you're going to get AI agents to pay for you. So they have to recognize that this isn't a fraud. So they're having to build these new payment systems to recognize that AI agents more and more are going to be buying things rather than humans. So that was quite interesting. It's something I hadn't really thought of, but yeah, you have to start thinking that AI is going to be doing all the purchasing. Uh, I told you there weren't many Facebook stories or Meta stories, and then boom, one turns up yesterday. Um, Manus, a company called Manus, is was a new Chinese agentic AI company, and they gave some amazing demos where their agentic AI was better than most of the competitors like OpenAI. And like I said, this was a Chinese company, and uh, Meta just bought them for $10 billion. So Meta's just bought this very well-respected up-and-coming agentic AI company in China. Meta just bought it out uh, yesterday. Um, this thing about, I mean, I've been talking a lot, always with the bad news showing you about job losses. There was a couple of interesting articles on TechCrunch about this in the past 2 days. Anthropic did some research on how AI is causing changes in the job market. And what they said was AI isn't actually replacing jobs. What it's doing is making people more productive, so you need less people. But the AI isn't actually doing the job of individual people yet. But they said it's coming. So we haven't really seen the full effect in any way. They say it's going to get a lot worse, is what the prediction is as AI takes over jobs. But at the moment, it's not actually doing a job. It's making people who you have is more productive. So what they're saying is power users are pulling ahead. The people who use AI and make themselves more productive are the things that are changing the job market. Um, a senator, American senator, I can't remember his name. Senator Mark Warner from Virginia. He came up with an interesting thing. Some terrible stats here that this is at an AI summit in Washington that was held yesterday. Entry-level job postings have dropped 35% in the last 18 months. And of course, big tech are just hemorrhaging people at the moment. But he came up with a solution that what we should be doing is taxing data centers. If AI is replacing people, then we should tax the things that are replacing people. This is very similar to an idea Bill Gates put forward that he said, just think of it as a thought experiment. If you have a human who works for a company, they pay taxes. If you replace that person with a robot, the taxes vanish. So the robot should pay taxes. It was a kind of thought experiment Bill Gates talked about just a few years ago. So, yeah, this is coming up again, this idea of taxing. If we're replacing human workers, we should be taxing the things that are replacing them, which is interesting. And from the folder of You Can't Make This Shit Up, Melania Trump wants a robot to homeschool your child. This was at the AI summit in DC yesterday. Melania Trump turned up, did a press conference with a robot, and talked about how we should use robots to teach children because they have more patience and they'll generate better cognitive skills. Obviously, she's an expert on this. Like I say, you can't make this shit up. So, yeah, that happened yesterday. That's my job gone then. And one last thing, do remember that next week, next Wednesday, there's this AI and the Future of Work conference from 3:30 till 6 on Wednesday. Look it up on the Oswego website. It's here. They just announced this morning that for those of you online, you can zoom into this as well. So it'll be running on Zoom as well. So you can turn up in person or run online. It's aimed at helping students get jobs. So probably a good thing to attend. Talking about AI in the workplace, and uh, there's actually breakout sessions on mastering AI, job search in an AI world, and things like that. So probably a good thing to look at. Okay, or attend next week. All right, let's carry on with where we were. We had um, we were talking about uh, the development of these large language models. We were using OpenAI and ChatGPT as our example model of how this is developed. And we'd looked at between 2010 and 2020, we had all the machine learning, but the big thing was this transformer model, completely different. Remember, it had these three properties: massive parallelism, which made training go from centuries to a few weeks on larger models. We could scale up. We had the big data centers. on that we could buy the processing power. And now, of course, the companies are all building their own centers. And the big tipping point was GPT 3.5. At OpenAI, when they had something useful, they switched it from generative AI to conversational AI, which is when, like I said, it took 5 days to get 1 million users. It was a tipping point, disruptive technology. So that's where we got to. And I mentioned diffusion models, showed you those. But there was an even bigger tipping point that happens in March 23. And we're going to look at what happened then right now. So we're in between these two orange bits here, which was our tipping point for AI. Now we're going to look at what happened in March 2023. Two major events hit simultaneously. And this is John's slide. He defined them as John's a cognitive scientist who's an AI expert, and he defined it as the spaceship landed on the front lawn. OpenAI released ChatGPT-4 in March 23. This is only 6-7 months after ChatGPT came out. So with the speed of development, things are speeding up. And the doors got blown off the barn. AI escaped. And that's to do with Meta's Llama model that escaped into the wild. So we'll show you what happened with that. So remember where we'd been? We'd seen ChatGPT 1, 2, 3, 1 million neurons, 1.5 billion neurons, GPT-2, 175 billion neurons, GPT-3. GPT-4 arrived. They didn't tell us how many neurons are in this. They kept it secret. But of course, AI researchers can reverse engineer this and look at what's going on. And the best estimate we have is it has 2 trillion neurons in there. We've done a jump from basically the brain of a dog to the brain of a human with this. It's an enormous jump. And also the difference between this one, yes, its size is way bigger, but it was trained on lots more data. It madcap stole the whole internet, this one. GPT 3.5, yes, they scraped it and it had quite a bit of data, but this one, they basically trained it on hundreds and hundreds of times more data. So all of a sudden, you've got this massive. They thought GPT 3.5 was good, but we had this enormous leap with GPT-4. All of a sudden, the magic sparkle, the attention mechanism just kicked in even more, and we start to get really complex, nuanced abstraction capabilities. Again, these are emergent properties. OpenAI didn't know what a model of this size that had read the whole internet would do, but they found out. One thing I forgot to mention was tokens. Remember, a token is a word. How many words you can put into the system? GPT-1, you could put about 10 words in. GPT-2, you could put a couple of hundred in. GPT-3, you could put 2,000 tokens into it. So you could put you could show the AI 4 pages of text, and it would read all that text and then work on that text to do whatever you wanted it to do. GPT-4 takes in, GPT 3.5 takes in 30 pages of text. So you can put 30 pages of text into it. GPT-4, not a huge jump, it doubled. It takes about 60 pages of text. So now, think how much 60 pages of text is and how long it would take you to read it. This thing reads it instantly. Not only that, it understands it and can work on that. You can give it 60 pages of text and ask it to convert it to French, summarize it, whatever you want it to do. So, Why was GPT-4 such a big deal? I'm going to show you a video that blew people away when it came out, when GPT-4 came out, because it really demonstrates the sort of thing it could do. And what this video is about, it's the OpenAI engineers are showing you they have a bunch of tasks that GPT 3.5 couldn't do. Yeah. And he's going to show you some of the tasks that 3.5 couldn't do, and then they put it in 4 and it just suddenly does it. Um, so let's have a look at one of those. We'll just look at one task. So here we are. We're looking at the transformer models. We're going to watch this video OpenAI. Remember, you're still taking notes for question 1, question 2 here. Why are the large language models different? And question 2, trends with large language models and agents. So do remember that. Right. Uh, as I said, we're just going to watch the first task. This first task is about summarizing an article. So he copies an article on GPT from a web page and then tries to get the language model to summarize it in a highly abstract way.
See, is the model capable of it now? And I'm going to show you the first one that we had a success for 4, but never really got there for 3.5. So I'm just going to copy the top of our blog post from today, going to paste it into our playground. Now this is our new chat completions playground that came out 2 weeks ago. I'm going to show you first with GPT 3.5. 4 has the same API to it, the same playground. The way that it works is you have a system message where you explain to the model what it's supposed to do, and we've made these models very steerable, so you can provide it with really any instruction you want, whatever you dream up. And the model will adhere to it pretty well, and in the future it will get increasingly powerful at steering the model very reliably. You can then paste whatever you want as a user. The model will return messages as an assistant. And the way to think of it is that we're moving away from sort of just raw text in, raw text out, where you can't tell where different parts of the conversation come from, but towards this much more structured format that gives the model the opportunity to know, well, this is the user asking me to do something that the developer didn't intend. I should listen to the developer here. All right, so now time to actually show you the task that I'm referring to. So everyone's familiar with summarize this, let's say, article into a sentence, okay? Getting a little more specific, but where every word begins with G. So this is 3.5. Let's see what it does. Yeah, it kind of didn't even try. Just gave up on the task. This is pretty typical for 3.5 trying to do this particular kind of task. If it's, sort of a very kind of stilted article or something like that, maybe it can succeed, but for the most part, 3.5 just gives up. But let's try the exact same prompt, the exact same system message in GPT-4. So kind of borderline whether you want to count AI or not, but so let's say AI doesn't count. That's cheating. So fair enough, the model happily accepts.
So look at that. The first one, GPT-4 generates groundbreaking, grandiose gains, greatly galvanizing generalized AI goals. And the second one, where you say, don't use AI, gigantic GPT-4 garners groundbreaking growth, greatly galvanizing global goals. Those make sense. They summarize the article, and they all begin with the same letter. He then does it with Q, and it works with Q as well. Humans struggle with this task. It's a really, really high level of abstract reasoning where you need a great vocabulary and you need a real depth of understanding of that article and of language to do this. So what we're looking at here is understanding. It's a totally new way we start thinking about these things. So What's going on here? Well, at the end of the day, it's still an autocomplete system. It's just generating text. But at the end of the day, isn't that what you are? If I'm talking to you, you're just generating text back to me. That's how I know you understand me. But there's a number of things that happened here with number four, with GPT-4, that in many ways were a much bigger tectonic shift than GPT 3.5. Linguistic finesse. It really began to understand emotion and sentiment, so it understood what people are thinking when they say something, what they mean. Really subtle features of text. Information synthesis. You can ask it to solve a problem, and it doesn't look up the answer from a single source. It learns all the knowledge in that field to be able to give you an answer by knowing all the knowledge in that field, not looking something up. It's putting all this knowledge together. Creativity. It starts creating music, writing books. And you can't tell them apart from humans. And not only that, you can get them, it understands style. You can tell it to write in the style of J.K. Rowling or Shakespeare, and it knows what to do. It has a deep understanding of literary styles and music styles. They're not only plausible, they're often better than the stuff created by humans now. We're meeting that level, and I'll show you some numerical examples that will prove that. Complex problem solving. Any new novel problem, things it has never seen before. It can not only solve it, it can break the problem down into smaller steps and reason through them. So we're getting this kind of level of symbolic reasoning in here as well. GPT-3 could give little bits of programming code. GPT-4 wrote full pieces of software. All of a sudden it's writing software. It's not just writing little functions to help you code, it's writing full pieces of software. Completely different. Yeah, it's doing it. And don't forget, it knows a lot. It ate the whole internet. It knows everything on Wikipedia. It's read every academic article ever published. This wasn't true with GPT-3. The data set was much smaller. Programming. It's read every code base on GitHub. Those of you who know programming, Stack Overflow. It knows every article on Stack Overflow. It knows everything about every programming language. Niche hobbies. Dungeons and Dragons. It knows more about Dungeons and Dragons than you do. Whatever you do, crochet, whether you do knitting, whether you collect model trains, it knows more about it than you do. And every Reddit thread, including all the humorous ones, it's read every Reddit thread. Sure, it still produces errors, but not that many. I mean, we always talk about AI producing errors, but the error rate's actually very, very low. It's better than if you asked a human the same question. So all of a sudden, we have this thing that's way better than a human at most tasks. It's kind of insane where it went to. Um, so, but let's go back to our philosophy conversations a little bit. We talked about consciousness, we talked about definitions of intelligence, but surely it doesn't understand anything, does it? They're just plagiarism machines, copying things. Chinese room experiment. John Searle smugly saying, a machine can never understand anything because it manipulates symbols. That's all it does. if I put in this Chinese character, the rule tells me if this, return this Chinese character. This thing has no rules. It has learned the same way a human learns, and it has learnt context and understanding. This thing actually understands. It doesn't work the same way that John Searle's talking about. It has understanding. So what do we mean by understanding? Well, how do you know that I have understood something you say? How do I know you have understood what's in this lecture? I give you assignments, I talk to you and see if you understand. This thing way passes that. It's way beyond the Turing test. I can I can tell you this thing could pass the assignments better than you can. You know? So here we are. We're now in this world where AI has surpassed us with its understanding. By any definition of understanding, these things understand now. So we can still argue about the question of intelligence because the definitions tend to involve embodiment and things like that. But is it intelligent? But it definitely has some form of understanding, even if it's not the same as our understanding. And these things are generative. So they're not pattern matching. Is this a dog? Is this a cat? Is this a spam email? Is it a real email? We're way beyond that now. These things are actually creating new things, new ideas, generating new things. They're still processing patterns, but they're processing them at such high dimensional space, at such a level of depth, that it's not just coming back and looking things up or comparing things. It's generating new things. And we've really started seeing this with GPT-4. It changed everything. GPT 3.5 was like a clever toy. It did some things and it was quite neat. It's like, wow, look at what you can do. And then GPT-4 came along and it's like, oh shit, this is like human now. And why is it this amazing? It's not just the transformer model, it's the scale. They've made it so big, which means it operates at such high dimensions. And they've fed so much information into it, just more information than we could ever get. Remember, the training for GPT-3 would take a single human reading 24/7 over 3,000 years. This is exponentially larger than that. We're talking millions of years of humans reading to get the knowledge that this thing has. So we put all that in a huge brain and allows it to have this depth. And what it's actually modeling is language. That's why these things are called large language models. It's a model of human language. So, any comments on that? You all knew this already. All right. All good. So, I'm going to show you how this works a little bit, this level of abstraction. But first, let's look at some other things that these models do. Computers have been able to do mathematics for years. So it's still got that ability. It knows algebra, knows math, can solve most math problems. Now we've taught it programming languages. Programming languages are rules. It's learnt the rules, the syntax of a programming language. And to write a program, it's like solving a puzzle, choosing which functions will perform, will work to achieve whatever goal you're trying to do. It understands the rules, it understands the mathematics, it understands the patterns, how previous programs have been written, the same as a human programmer does. And it can learn to build answers or programs to using those rules. Natural language is a little bit different. It's something that human brains evolved from apes. We've over millions of years developed this ability to be able to speak to each other and write things down and transfer language. It's an interface by which we all communicate and collaborate. The LLM has learned that language the same way, in many ways, the same way as a human does. It's learned a language. And as these LLMs get bigger, it absorbs more of these abstract patterns in language. It gets more and more complex ideas about the relationship between words, which is what we do as humans. When you're a child, you learn words like ball and car and dog, but you don't understand all the relationships between those words. That comes as your brain develops. And it's the same here. The LLM, as it's got bigger and more complex, has learned more and more about language and those relationships. And now it can solve problems. It has all this knowledge from the internet, the whole goddamn internet. It can, so long as you can put your problem in language, it can try to solve that problem using all its knowledge. Again, this was new in number 4. As you saw, number 3 didn't have a high enough level of abstract reasoning to really think like that. So some of these abstractions, what kind of things is it learning? Well, the obvious ones are syntax and grammar. Let's face it, I'm a professor. I think I write reasonably well, but I still use Grammarly to correct my grammar. You know, these things are still useful. They know more about grammar than we do. Semantic relationships, the relationships between different words. Metaphor. Think of Shakespeare. Juliet is the sun. A rose by any other name. These kind of complex metaphors. It begins to understand metaphor the same way a human understands it. Pragmatics, the rules of logic. But all this affect emotion and tone. It understands whether someone's angry, the emotional impact of certain words, and it understands things from culture, idioms and references. It understands memes and jokes. But that's pretty clever to understand all that. But there's an even higher level that GPT-4 now started to understand. Perspective taking. Can think about a problem from the perspective of a Democrat or a Republican, from a female or a male, from an old person or a young person, from someone American or someone Chinese. It can understand the difference. So it can take a point of view. What does that make you think of? What does it mean to be a bat? It can take a point of view. Now, it doesn't have the subjective experience that, humans don't have the subjective experience of being a bat, but we can take a perspective from someone else. We can put ourselves in their shoes, as we say. The AI can now do this. It's a uniquely human level. There's no animal does that. This is way up at the top level of human processing. causal reasoning, why something happens, counterfactual thinking, conceptual blending, blending ideas together to create new things, common sense and heuristics, symbolic reasoning, top-down stuff again, all the rules, and ethics. It can start to understand morality and ethics. Now, GPT-4 didn't do all of those second ones perfectly, but it was doing them and pretty well, as well as any human. So it's kind of crazy. This is where we were, and this is 3 years ago. This is where we were 3 years ago, March 23. So let's look at um, this magic sparkle, this attention mechanism. What does it do, really? This is a very, very simplistic explanation of the kind of multidimensional process here. Let's take a metaphoric sentence. She is the wind beneath my wings. It's a song title, but it has a meaning. Barbara Streisand song. Barbara Streisand made this song famous. So you've got this song, She is the Wind Beneath My Wings. What does that mean? What does it mean? You're all humans, and AI knows what it means. Yeah, she pushes someone forward. Me. She pushes me forward. She lifts me up. She helps me. She motivates me, that kind of thing. That's what it means. But the words motivate, lift, empower, none of those words are there. Yeah? They're not there. So how do you know that without knowing the whole context around it? You have to understand the cultural context, the history of work, all this stuff that we've inherently inbuilt through our lives to understand this. So the way the computer does it is it starts building these semantic relationships. There's two objects here, she and me. Yeah. And she is doing something to me. Yeah. There's two objects, the wind and the wings. And the wind is kind of doing something to the wings. So we've got she and me. She is the wind, so she's related to the wind. I have wings. And she's doing something that is lifting me up. And so overall, this is an uplifting thing. So we've got the two objects, the two subjects. We've got one object has, one subject has the wind, me, she, me, the other subject has the wings, she has the wind. Yeah. So, and it's uplifting. So you get this kind of pattern that an AI can see this pattern of how it works. But then it looks at millions and millions of these examples. So when it sees a new one, he is the fire in my heart, it can just apply this pattern. And there are just millions and millions of these that it can understand. Now, what you need to realize here is this is just one level of abstraction. It can go 50, 60 levels deep of abstraction to understand what the sentence means. This is just an extremely simple example of the kind of things it is doing. And this is what the attention mechanism does. Allows it to start understanding things, the magic sparkle. So the second thing that happened, check time. Second thing that happened was the doors got blown off the barn. This is meta. Facebook. Facebook developed a large language model called Lambda. Uh, Lambda stood for Large Language Model Meta AI. That's what it stood for. I don't know why, because you've got large language, but then they've got an A, and then instead of two M's, they've only got one M. Model and meta, they got one M, and then they got AI. But that's what it stands for. Large language model like meta AI. So Llama came out. Their language models were way smaller than OpenAI. So GPT-4 came out and it had 2 trillion neurons. Yeah. Meta's biggest model was only 70 billion, which is all the way back to, it's less than GPT 3.5. It's between GPT 3 and 3.5. So these were smaller, but Meta built them smaller on purpose so you could run them on a PC, a high-end PC, but you could load the whole model on a PC, a high-end PC, and run it, run on local hardware. And this, they were giving out to universities and researchers to do research on large language models and develop the models further. Along came 4chan, the hacker group, and 4chan stole it. They stole all of Lambda's models and put them on the internet in March 23. Data is infinitely replicable. So Lambda, everyone suddenly had their own AI model. If you wanted an AI model, or if you wanted to train your own AI, you had a model. You could run it on a PC. So all of a sudden, millions of people got AI models for free. Didn't have to pay anyone, and they were private. You could run them on your own computer. Completely changed everything because all these companies started sprouting up. What do you think they were using? They're all using Lambda because it was free and available. So all of a sudden, all these AI companies started appearing because they had free access to these models. They weren't having to use someone's pre-trained model and pay for it. So yeah, this changed everything. So yeah, so 2010 to 20, we saw the transformer model. 20 to 22, generative to conversational, GPT to chat GPT, a tipping point. These two things that happened in March 23 completely changed completely changed everything. GPT-4 was such a big step from GPT 3.5, and free AI models became available, which was a way bigger tipping point in many ways than the conversational AI. So this thing now, we have models, we're only up to March 23, 3 years ago, and we have models that can understand language. They capture these complex knowledge patterns. So we've started to see these complete complex knowledge transformation is possible, and we have free access to a whole bunch of these models. So, and the thing to remember is, even at this time in March 23, as it is with every technology I show you, this is the worst it's going to be. These things are only going to get better. So we're only up to 23, 24 here. Now let's look at what happened in the last 3 years, which is even crazier. So first thing, I wake up, there's a new technological advancement. the number of models coming out, I talk about this all the time, is staggering how fast they're coming out. Um, where we are in 24 was the peak of model development. When we hit 2024, this is when all the models were coming out at the highest rate. Um, there's this great paper which is on Brightspace from TechCrunch. It's called Too Many Models. And this is written in April 24. And he describes how many models have come out in the last week, and there are 10 of them. And he says by the time he'd finished writing the paper, there was another one had come out. Now, these are all models from the big major companies, but there's a Llama model, a Mistral model, Stable Diffusion, who do all the image generators, the diffusion model. Adobe Acrobat brought one out. There's a Cohere model. Remember Cohere I talked about? And NVIDIA's just given them $100 billion in partnership. So yeah, all these models were coming out. And we'll look at how many models were coming out over time in a moment. So let me go jump back. So what happened? So we're only still around here. We're just going into 2024 now, and we're going to see what's happened up to 24 to 25. Let's look at that. 6 months after GPT-4 came out, GPT-4o came out. This linked to a ton of multimedia stuff, so audio and video and things like that. They improved the conversation a little bit, and they're now up to 128,000 tokens. You can put in 300 pages of text into the AI. It reads it instantly and then summarizes or does whatever you want to do with that text. 300 pages of text in one conversation. 4 months later, they brought out GPT-01. GPT-01 was designed to think longer about problems, so it could tackle more difficult problems, especially science problems. GPT 4.40, 4 months ago, there's a test that is, they have a bunch of tests for PhD students. And GPT 4.40, 4 months ago, scored 13%. GPT-01 scored 83%. Now, I have a PhD, and so I should be able to answer questions on computer science to around 80, 90%. This one can answer questions on any subject to that level. So, also, the coding ability, this is September 24, what's that, 18 months ago? The coding ability was compared to the top 10% of coders in the world. We're reaching that level here. January 25 was a big upset. China released DeepSeek. This was a free model that worked better than OpenAI and Gemini. And it was a much smaller model that worked better than OpenAI's huge trillion models and Gemini. How did they do that? So their model was outperforming even O1, this new OpenAI model. Their R1 model that was released in January 25 was outperforming because it uses this thing called a mixture of experts architecture. I'm going to show you what that is in a second, which makes the models much smaller. We can still scale to trillion parameter sizes, but we don't have the inference costs. It's a much cleverer way of doing it. So how does it work? It's a machine learning technique where you have multiple transformer models. So instead of one big model, you build 10 smaller models. And these are considered 10 different experts. You train them in different ways. They're considered different experts. And then you use another transformer model to bring all that together. So this is the mixture of experts model. It's also called ensemble learning. And so all of the American companies suddenly switched to using mixture of expert models. Within 3 weeks, Google released a version of Gemma 3 that used a mixture of experts model and could match what DeepSeek was doing. So they all switched to try and compete with DeepSeek. It pulled the rug out from under them, and all the American companies battled to keep up with this Chinese company. I told you only on Tuesday that the news has just come out that DeepSeek are releasing version 4 in the next 2 weeks. So we'll be watching out for that. And DeepSeek version 4, they've claimed, or the leaks claim, they have a mixture of experts version 2 that is much better than version 1 that they've developed. So we don't know yet. It hasn't come out, so we'll have to see. But just as I showed you how mixture of experts work, this will be interesting to look at in too. So we're still only up to January 25, 1 year ago. This is where we were. What happened next? August 25, GPT-5 came out. GPT-5 is not one model. OpenAI now built a whole series of models for different things. They have a model for programming. They have smaller models for quick, easy tasks. They have more detailed, large models for handling complex scientific questions. And when you type something into GPT, it decides which model to use to answer your question. Hallucination and errors dropped by 80%. That's huge. They reduced errors by 80%. It was pretty cool. This came out 6 months ago. So they've got improved reasoning and accuracy, better coding, it writes better programs and math, reduce the errors and hallucinations. It now takes 400,000 tokens. That's 800 pages of text you can put in at once to this system and ask it to read it and summarize it or do whatever you want with that text. It's faster. Now it's all about agents. Like I said, in March 25, there were no agents when I taught this class last time, and now they're everywhere. And it understands media better. You know, they've integrated even more video and image stuff. So remember GPT-4, how big it was? 2 trillion neurons. Let's have a look at GPT-5. This is a guess because again, OpenAI haven't released it, but when GPT-5 came out, the best estimate anyone could have was 10 trillion, which is only a 5 times increase. Previously, they were jumping up 100 times. And people were a bit surprised by this, that it wasn't as big an increase. Recently, people have stopped talking in neurons. They tend to talk in parameters now. And this has only happened in the last year or two. So when you talk about a new model, we tend to talk in parameters. These are the connection weights. How many connection weights in the model? Usually, and the best guess anyone had for 5.0 was 5 to 20 trillion. And the tokens you can put in 800 pages of text. So this was 6 months ago. By February last month, there've been three upgrades: 5.1, 5.2, 5.3, but they were all benchmark upgrades, just making it a bit faster, uh, a bit better. The big increase in 5.3 was a whole new programming option, the coding ability. Anthropic had started to win. Anthropic Claude Code is regarded as the best one AI for writing programs, and Opus 6 was 4.6 was out was currently is still currently being used. So GPT 3.5 released a whole new coding thing to beat that. But they didn't change much of their model until GPT 5.4. So 5.3 came out 1 month ago. 5.4 came out 2 weeks ago. And this is lots more stuff for agents. GPT 5.4 can take over your computer and use all your software to solve a task. You give it something to do, it can jump in and start accessing your computer and solving things, executing tasks like a human. When we start looking at agentic stuff, I'll show you some examples of how this works. The context window, the tokens, it now takes in 1 million tokens. That means you can put 2,000 pages of text into this thing. Mind blowing. You can put all the novels written by an author and ask it to analyze those novels. Entire code bases or massive document collections can just be dropped straight into it and it'll answer a question on them almost immediately. It also has a thinking mode, so it can answer problems more deeply. And again, they dropped the number of errors by another 30%. But here's the big difference, though. They scaled up quite significantly from 5.0. Again, they don't release this information, but the experts who reverse engineer these things and work out what's going on, they believe the current model, GPT-4, 5.4, remember, GPT-5 is multiple models and GPT decides which model to use. They have small, medium, and large models. The large models are around at least 10 times bigger than the small models. So we said they'd only gone up about 5 times, but the large models are about 50 times bigger than GPT-4. So minimum of 50 times bigger, probably more like 100, which is the normal scaling we've been seeing 100 times every new one. So yeah, this is where we are now. That only came out 2 weeks ago. So now we still don't really know how big these models are, but we're kind of getting into some idea of how many trillions of parameters. There's an article on Brightspace that's a complete history of OpenAI models from GPT-1 to 5, where I got a lot of this information from, but there's other places as well. But a lot of this information came from there, so go have a look. Of course, I've just been showing you OpenAI and ChatGPT, but there are many, many others. I mean, the big ones are Google. DeepMind is their AI division that makes Gemini, Microsoft AI, Anthropic, who makes Claude, Meta AI, whatever they're doing these days, Amazon. There's a few interesting ones on there. Cohere, we've mentioned a few times. Mistral, the ones who brought out the new model today, do mainly language. Salesforce is an interesting one. They were a marketing company that did telesales, and they're now one of the biggest AI companies in the world. They grabbed AI very early on, and then there's all the Chinese ones like DeepSeek, Alibaba, Baidu, as well. Just lots of these companies. All right. So to finish this section on LLMs, I'm going to show you some scary trend graphs of what's going on with large language models. But before I do, any questions or comments? Everyone okay so far? All right. This is where it gets a bit scary. Start seeing some of this. So this is how many large language models have been brought out by the big 4 or 5 companies. Okay. So we're not looking at all the companies here, just the big 4 or 5. And we hit a peak, as I said, we hit a peak in 24 where there was basically 4 or 5 models coming out every month. We've dropped a bit. There's now 3 or 4 models from the big companies coming out every month. So still insane amounts of models coming out, but we've dropped a bit from the peak in 24. You can look at all these models and follow them. We did OpenAI, following OpenAI along the bottom there. And this is just from 23. This is just 18 months from February 23 to August 25. No, not even 18, 14, 16 months. So you can see how many models are coming out from all these companies. It is exponential. This is the number of parameters along the bottom. As the years go on, the number of parameters are just going up and up and up. You can put all these AI models onto the chart and see how they fit on there. So this is a parameter count, particularly looking at GPT. So you can see from GPT-2 to GPT-3, Lambda was smaller, the one that got out in the wild out there. GPT-4. Now it looks like GPT-5 isn't much bigger, but that's 5.0, the small model, remember. The large model is 10 times bigger than that on GPT-4, 5.4. Interesting statistic. In about June of 2025, May 2025, this was May 2025, some research was done that showed that more articles on the internet are written by AI than human. 52% to 48% written by human. Obviously, it's much worse now. This was 10 months ago. So what's happening is lots of articles like this, over 50% of the internet is now AI generated. But this is leading to an interesting problem. The internet's going to die, or at least change into something else. How do websites survive? New York Times, for example, yes, you can buy a subscription, but most of their money comes from advertising. Humans look at their pages and they advertise to you. If you use an AI system and ask a question and it gets the information from the New York Times, no one's seen the advertising. So there's this thing where the internet is going to die. The internet is going to be generated by machines and read by machines. It's already happening. We're already over 50% of it is generated by machines. And the way it's being read now, I don't know the actual figures, but I can guarantee it's probably around 50%. It's read by machines, not humans. So it's going to change into something else. The internet is dying, as it was. You know, when I want to know about a movie now, I used to go to IMDb and Rotten Tomatoes. Now I use an AI that accesses those sites and brings me all the information in one place. You know, why wouldn't I get more information from multiple sites? Yeah, so this is changing. This is a really important one, but it's a very difficult graph to understand. This is about science, and all these little lines are measures of improvements in AI doing science. Okay? So the important thing is the line at the bottom. This is up to this is a current graph that goes into 26. AI is now doubling the length and complexity of science-based research tasks it can handle every 4.5 months across 9 benchmarks. So, what does this mean? If you work in a biology laboratory or a medical thing where you're folding proteins or doing whatever, and you have AI helping you, and that AI can do a certain tasks in your laboratory, yeah? Every 4.5 months, the amount of tasks that and the complexity of the tasks that AI can do doubles. Every 4.5 months, it can do twice as hard work, science, and twice as much of it in the same time. So I was telling, I think I may have mentioned this statistic about medical data and how fast it's doubling nowadays. Every 3 months, we double the amount of medical information in the world. This is exponentially increasing. So this idea and that time scale of 4.5 months is shrinking. This is an exponential graph, by the way. So that time scale is shrinking. So at the moment, we double the science capacity of AI every 4.5 months, but probably by the end of the year, we'll be doubling it every 2 or 3 months or faster. This is an example from, this was quite a famous graph when it came out. It caused quite a stir. This is about AI writing programs, coding tasks. And it's a graph of what tasks, how long it takes an AI to do a particular programming task. Yeah. And to a successful rate. And it goes from 2021 up to 2028. So the predictions, okay? Now, the straight line prediction is exponential. This is an exponential graph. Every gap is 4 times the previous value. So so every time you go one little gap here, you're getting 4 times faster, and the AI can do 4 times as much programming in the same time. And so the exponential curve here, which they show as a straight line, a trend line from this graph came out in early 2025, and the prediction was if we keep going at an exponential rate, it will be this straight line. But they also have this super exponential rate, which is even faster. And here we are. This was at the start of 2026 when GPT 5.1 came out. Remember 5.3 is even better, but I don't have a graph with 5.3 in it. But you can see we're actually developing faster than exponential. So the rate of increase in what these computers can do from programming is faster than exponential. But we're not at super exponential, but faster than exponential. As the guy said in that article I showed you on Tuesday, they're cutting their staff because no human will ever program again, is what the CEO said of the software company. Quite frightening. Stories like this come out. This came out just last month. A math startup company solves some maths problems that have never, ever been solved. They literally trained AI on mathematical problems and the AI just solved them. These are things that the whole human race has been unable to solve for hundreds and hundreds of years. And they just trained an AI. They started a company. Within 2 months, they trained an AI and cracked 4 unsolvable problems. This is what's happening right now. Every month, something like this. It's all right. Um, this is the training speed or processing power of the models. And you can see that in terms, and basically we've got all the different types of AI up on the right-hand side, gaming in AI, speech, language models. The green ones are the language models. And it goes all the way back to the 1950s. So you can see that we have this slow development until we get into the 2010s, 2020s, when the transformer models come out, the curve suddenly gets a lot steeper. So we're developing a lot faster. What you're missing here is this is an exponential graph. The jump between every bar on the y-axis is 100 times. So you're getting 100 times faster every bar on the y-axis. Let me show you what this looks like. I created a graph of this shown on a linear graph. There you go. The red dots, this is the processing speed of training of AI models all the way up to 2023, and then boom, straight up. That's where we are now. We're just continuing to go straight up there, like that. That's what happened. This is just an interesting one. It's not a particularly not very scientific one, but believe it or not, Americans are the least excited people about the most worried about AI of all the people in the world. Every survey has shown this, multiple surveys have shown this, that Americans are more negative about AI than anyone else. But when you look at countries like India and South Korea, who are really embracing this technology and running with it, in some ways that's a bit frightening, that they're running with it far more than we are. There's no figures for China. I don't think they got any data. I don't know. But it's interesting. Australia's up at almost the same as us as well. Just a interesting chart. There's a whole bunch of articles on this when these figures came out, if you want to have a look at them. Why do Americans say they say it's uniquely American, but Australia's almost the same. So I don't know. All right. Remember the boom and bust phase? This is where we're going to finish. A lot of people are saying that there's going to be a bust in AI as well. There'll be a crash, a market crash, like there was the dot-com boom. The reason for that is the dot-com boom was caused by people investing too much money in companies that weren't making a lot of money. And what's happening right now? Everyone's investing in AI companies that aren't making a lot of money. So there's a very real chance we'll have a bubble effect, we'll have a crash. And what's going to happen with that? Lots of articles on this right now. But what's going to happen with that is what happened with the dot-com boom. The internet didn't go away, social media didn't go away. It just meant that these companies weren't worth as much money. It's more of a financial thing than a technology thing. The technology will keep going, but the big companies won't have as much money. Cohere. We've talked about this company over and over. This is the CEO of Cohere. She used to run AI research at Google. What she's saying right now is we can't scale these things anymore. We're hitting a ceiling of how big we can get and get more benefits. We need to do something else. So they're betting against scaling. Like I say, Nvidia has just given them $100 billion because of this, because they're doing something different, not just scaling up. Head of Google DeepMind, Demis Hassabis. Anyone heard of this guy? He got the Nobel Prize last year for chemistry. Why for chemistry? Because he wrote that system that does protein folding using AI, and he gave it away for free. And so they gave him a Nobel Prize in chemistry. Anyway, he said just in January this year, he said, we've done the same. We've reached a point we can't scale anymore. We have to use world models. So this idea of bringing the symbolic stuff back and all that I was talking to you about is what they're all talking about right now. World models, old idea, might come back. Next idea, world models. Remember, I gave you this piece of news. This happened about 2 weeks ago, 2.5 weeks ago. This guy got $1 billion for building world models. Very interesting kind of activity. So we're going to finish this section. We have just enough time for me to show you a few world models. What are they? I might run over by a minute or two, but I just want to finish this section. I don't want to leave it running. So, world models.
Let's talk about one of the most exciting developments in AI, world models. Most AI today is like a very talented autocomplete. It reacts to what you type, what you click, and what you show it. A world model is different. Imagine you're trying to walk through your house in the dark. You don't need lights on to avoid the coffee table because you have a world model in your head. You have a mental map that predicts where things are and what happens when you take a step forward. In the world of artificial intelligence, we're trying to give machines that same superpower. Currently, most AI acts like a clever parrot or a very fast calculator, but a world model allows an AI to build an internal simulation of reality.
Because we're running out of time, I'm going to stop it there. But there are two videos on world models. If you want to know more, you can watch them here. But because we're running out of time, I'm going to jump to showing you some demos. So Google have built a world model called Genie 3. They released this about 10 months ago, and it builds 3D models, 3D worlds like in a video game. But here's the thing, when you build a video game, you build a world like the world of Skyrim or Assassin's Creed. But you've built this world, it doesn't really change, you know, you can interact with things in the world, but you've built a 3D model. There is a 3D model, but the computer is the large language model equivalent is generating the 3D model as you move through it. So the world doesn't exist, that hasn't been built. The language model is building it as you look around it. So I'm sorry to run over a little bit, but let's just see how.
What you're seeing are not games or videos. They're worlds. Each one of these is an interactive environment generated by Genie 3, a new frontier for world models. With Genie 3, you can use natural language to generate a variety of worlds and explore them interactively, all with a single text prompt.
You're controlling movement in this world, like a game world. You're walking around it or flying around it.
Let's see what it's like to spend some time in a world. Genie 3 has real-time interactivity, meaning that the environment reacts to your movements and actions. You're not walking through a pre-built simulation. Everything you see here is being generated live as you explore it. And Genie 3 has world memory. That's why environments like this one stay consistent. World memory even carries over into your actions. For example, when I'm painting on this wall, my actions persist.
So it's quite amazing. I put some, you can't actually get in and play with this, yes. It's still in closed beta. I've been trying to get in and play with this for months, and I can't, I want to start using this, but I can't, I can't get my. They've closed the wait list for the world beta, so I'm waiting for it to come out to allow us to play with it. But there is one called World Labs from a Chinese company that you can actually go in and start playing in. So here's one of their worlds models. I'm using the mouse to just move around in this model. And this doesn't exist. It's being generated in real time as I move around it. So the world is being built in real time as I move around. So you can go in and play with some of these. Anyway, that's it for today. World models. So that's as far as we've got with LLMs. Next week we'd start looking at agents. We'll do a class on agents, and then after that we're going to start looking at artificial general intelligence and super intelligence and singularities. All right. Okay. See you all soon.